Hi everybody, this is going to be an introduction to making our first program for our robot. And right off the bat, I should apologize because I do not think I'm going to edit this video, so it might be longer than if I chose to cut some things out. I won't have any fancy transitions. I'm really just going to be showing the website, coding, and just getting right into it. So yeah, let's get started. The first thing I want to mention is that this website, WPI Lib, is a website that talks about pretty much every single aspect of either building or coding your robot. WPI is the institution, or I believe the university, that creates the main code for the FRC robots. And this is all just documentation on the different things you can do, such as building your robot, installing the software, preparing your robot, programming your robot. Essentially, when I first knew that I was going to join this team, I spent some time reading each section, and it would help you too if you did the same. But for now, we're actually just going to skip right down to step 4, programming your robot. The building is going to be done in person. And hopefully you've been able to install your own software by following what's in the wiki or with any of our help. And then preparing the robot is just like the setup, which will also likely be done. So we're going to, again, go into the programming. And what's going to be very difficult about this is that we are programming a robot that's not yet built. But that's part of the fun, I suppose. So I'm going to follow this guide and kind of show you how I would have learned how to set up a program for the first time and then run and test it. So here we go. Step 4, programming a robot. One thing I want to mention is there are 2 different languages used. There's LabVIEW, which is, for all intents and purposes, called the kiddie version of robotics. It's more visual. It's not an actual programming language. Then there is the C++ and Java aspects of coding. Sorry about that. So anytime you see that you have a choice, you're always going to be going to the C++ Java. That's the actual written code. So let's go to the link that says creating your benchtop test program. And apologies if my computer is a little slow. Well, here we go. Creating your benchtop test program in either C++ or Java. You are going to want to read this all in your own. I am going to kind of skim through it and kind of do this as like a visual how-to if you are getting confused following these steps on your own. Now, this is assuming that you already have your full code editor installed, your WPI lib version of Visual Code. And these are already pre-installed on our laptops that we use in the club. But let me bring it up. WPI lib, there we go. That should load, perfect. So here I am with a blank editor. I am going to X this out. I'm going to open a terminal. No, sorry about that. I'm not going to open a terminal. I can expand or make this smaller. So I guess for now, I'll just have this full empty screen. Right, cool. So I'm staring at nothing right now. What is my next step? So to create a new WPI lib project, you're going to bring up Studio Code, which we've did. And you can hit Control-Shift-P. Does it give what to do for a Mac? I don't know if it does. I'm assuming it's probably the command. So we're going to do Control-Shift-P. And we're going to type in WPI lib. And this in Visual Studio Code is a way to bring up different options of extensions. So I'm not going to get too much into that, but it's going to let us search for all the different tools that have WPI lib in their name. And then when we do that, we're going to want to create a new project because right now it's just blank. And it will bring up this new project creator window. I'm going to run through this kind of step by step. But okay, so it was Control-P. Sorry about that. It's been a while since I used Visual Code. Control-Shift-P. Okay. P. It shows my recently used, so you're already going to see WPI lib create a new project, but you might not see it at the top. So let's just pretend. All right, WPI lib, and I know I need a new project. And it kind of uses a search feature. That kind of goes by the term like fuzzy logic, which means that even if you kind of like misspell things, I'm typing really fast. Otherwise, I guess. But yeah, I know I want to make a new project. I know I'm using the WPI lib, and most things you're going to be using something that comes from WPI lib. This is their pre-made programs. So we click on this, and what's really cool is it brings up this project creator, and it's going to generate all the files we need, and then we can kind of examine what files specifically we're going to want to either edit, change, or what folders we're going to add to. Now, in their example, they're actually going to want to run us through not a clean like template to work with, but we're actually going to download one of their example projects. And so this is really just going to be able to show us like something that's kind of pre-made, and we're only going to maybe have to change a few things. So we wouldn't be using one of the examples for competition, but it kind of shows us how things are working. And let's just pretend we don't know anything at all. We're going to follow the numbers and the steps. Number one tells us we have to name what kind of project type it is. So again, you could choose either an example or template. Let's do that. They want us to do an example for this one. Then it brings us to step number 2, which lets you pick the language. So we can either use C++ or Java. Most teams use Java. We are a Java team. And there's really not much extra use to using C++, considering that it's slightly more complex. So we'll click on Java, and now it says select a project base. Because we're doing an example, it's going to give us different pre-made projects to choose from. So the cool thing about this is they give us kind of pre-made projects that if you want to download and kind of pick apart, it's a good way of learning like how they would do something. So they have a program for showing if you want to set up a robot that just drives. There's 2 different drives actually we'll learn later. Tank drive drives like a tank, arcade drive drives like a little arcade car. This is also a different type of driving chassis, or it drives differently. They have examples on how to like potentially code an elevator, how to use a gyro. If you get like a vision, a camera set up, how to code and integrate that, how to make a Frisbee bot. So there's a lot of like pre-made things that help to kind of study if you're really confused, because them being the people who actually make this code base, you would trust that their examples are probably the best examples to learn from. But let's see, this is the first project we're making, and we're kind of following step by step. And what do they want us to use to get started? We're going to use the Getting Started project. Okay, right over here. That's right at top. That makes sense. Now the next thing is just going to tell us where we want to save this. I don't think we have come to a consensus yet as a team where we're going to be saving our folders. I've noticed there's a lot of desktop saving that goes on, but eventually I assume we'll make a folder just to keep all our different projects, just so we don't get confused. I guess I'll just put it on my desktop for now. And then we'll give it a name. Do they want us to name anything specific? Probably not. Yeah, so the name is just for you to kind of find it. Our first project. And I'm naming it in camel case, if you notice. That means that, well, camel case would actually be this one lowercase, but you don't have to do that, especially when you're naming things. But when you do program, you're going to notice I do a lot of camel case. And that's a convention that programmers do to kind of piece out the words in long variables or functions. And then we're going to pick our team number, which I believe is 3950. If you get this wrong, that means that you can't connect to the robot. So for a sample, I guess it's okay if I got it wrong. But if we're actually making code that we are going to connect to the robot, we want to make sure we get the team right. And this is something I really should know as a mentor. And this is something that I'm sure is going to be cemented in our brains as we go forward. But the team number is how it kind of checks that we're actually connecting to our robot and no one else's robot. So this code is being made for our robot. It has an ID that relates to this 3950. Lastly, this thing right here, enable desktop support. It's going to be up to you if you want to like choose this or not. I usually keep it open. I've heard that some people don't like to do it because they think sometimes it can mess with pulling in. Let me say this: if you get like a part that's like not really one of the more common parts, sometimes it doesn't go well with this because the desktop support lets you do like the simulator, which is not like fully developed yet. It's still very buggy and it is not going to be used a ton. It's much better to use a physical robot, but it does have its use cases sometimes. So I'll use it here, and we're going to generate the project. Project successfully created. Would you like to open the folder? Yeah, so you can open it in the current window or open a new window if you're afraid you would lose anything. This is brand new, so this is the current window. And here we go. You always get a welcome screen. You can exit out if you want. Sorry, these are popping up because I downloaded some extensions. I don't know what this is. All right, cool. And you can even X this out. So we're just completely empty. So this is where your text and code is going to go. This is your file, not hierarchy, your file tree. Oh, there's a better word for it. But anyone who's familiar with computers, like Windows computers, Linux computers, it's a folder with subfolders. You just kind of have to find where your code is. And the cool thing is, you're never going to need pretty much 98% of this. Doesn't matter what Gradle is, VS Code, this folder is just for things related to the editor itself. The only thing you're ever going to open, like 99.9% of the time, is the source folder. And inside the source folder, you're never going to open up the deploy. That becomes like kind of binary or assembly code that goes to the robot, I believe. So that's always going to be ignored. You're actually going to go to the Java. And it's these files in here. These are the only files you're ever going to code. Or you might end up adding like a new class or command inside here. But pretty much you're always going to go source main, the Java, and then it brings you to where anything that you were actually going to be coding or changing will go. Okay, cool. So what else do they want me to do? We did all these. Opening new project. We opened it. Cool. So now we're actually going to get straight into coding. So they want us to... Hold on. I guess I want us to go to Robot Java to start. All right, cool. So this is definitely going to be a more simplified version of what you're going to see when we code. This is literally only 2 files, and we're only going to code this robot to drive, and that's literally it. It can do nothing else but drive, and it only, I believe, has 2 motors. So it's essentially having a robot with 2 motors attached and just coding it to drive. That's it. But this is an example project for us to just kind of see the structure of it. So the cool thing is they're going to kind of just walk through the code and explain what each piece is. So they show this, and I think they're going to actually kind of zoom in on some stuff right here. So usually the first thing you're going to see in any kind of Java file are your imports. Includes if you're doing C++. We're not. You're only going to see imports. Imports just means you're taking a library, opening it up, and now you can use any of their code. So for example, if you're going to use a joystick, WPI-lib has a joystick library that has all the different commands and functions that a joystick can use, like get joystick value of thumbstick, things like that. We can pull different types of motors. So this is a specific motor, PWM, Victor SPX. So if we're going to use a motor, we're going to have to actually import all the information about that motor because they wrote code for us that says like, oh, if you have this motor attached, then you can use like set motor speed. And these are just always going to kind of be made for us, these ones. And these are, this goes with the creation of like the whole file system. And this one is the drive code that's written for us. So inside the WPI whole entire library, they have a specific library. It's called drive. It has different types of drives, like there's an arcade drive, a differential drive, so many different kinds. And we're going to actually look into this specific one. Now, if we wanted to use a different drive, we would search and say, oh, how do I import blah, blah, blah. Let's see, we should have the same stuff. Yep, so we are importing a joystick, importing one of the motors. If we're using a different motor, then we would just kind of find that motor and import that one instead. And we're importing differential drive. Now we're going to go to the next thing. It actually gives us a comment, kind of telling us what it is. Oh, we don't have to worry about this one, actually. Sorry about that. In Java, you're eventually going to learn that you create things called classes. We're not going to get too much into it, but this is just the creation of this very small specific robot that's going to have two motors and will be able to drive or power the motors. And when you do that, usually the first thing you're going to see are these things called field variables, or just think of them as variables. You're basically saying that, hey, I want to make a drive train or an engine. It's called differential drive. But think of it as an engine. So you're saying make a brand new engine. Its type is a differential drive because there's different type of engines. Name it mRobot Drive. You can really name it anything. Name it Taxi, Bob, Chris. This is the name of the variable or the name of this specific instance of our driving robot. You're going to see this M dash a lot. I believe that the convention is when you're making a class or like a specific robot for like a one-use kind of thing, you put this M in front. I'm gonna have to look up what it stands for, but it's almost like, oh, just for now, this is like the one we're gonna like use. Terrible explanation, but I can explain it better next time in person. But this is basically saying we have this new engine. I'm gonna name it mRobot Drive, and what it is it's this type of engine called a differential drive. And if we were to look up what differential drive gets, it would tell us that it takes in two parameters. It takes in a one motor and two motors. In fact, I'm supposed to highlight over it. Yeah. So you'll see right here. This type of engine, a differential drive, requires that you put in a left motor, come on, a left motor and a right motor. So we're actually putting into this the left motor, which is plugged into, we'll call it a port 0. Like it's wired to the 0, and this one's wired to the port. This is 1. When you get to look at the robot, you'll see that it has a bunch of different connections that you can connect wires to. Port's not the correct term for it, but think of it as a port. So there's like an empty, let's pretend a USB socket, that's 0, and an empty USB socket, that's 1. It's not USB, it's electrical, but it's knowing that the one on the left will be a 0, the one on the right will be a 1. We are making a brand new joystick, so we're saying take joystick. Let's call it mstick. And this is a joystick that's going to be plugged into, this actually does mean port. This one's going to be the USB port that it goes into. So your computer has different USBs ported from like 0, 1, 2, whatever. They all have different numbers. And I'm going to ignore the timer part for now. Let's see. What are we missing? What did I not go over? So we talked about the variables. And again, this will be on you to like read this and understand it more. I'm explaining it, but the explanations are here as well. In fact, it might even do a better job than me because I feel like I'm even rambling a bit. So we talked about our imports. We talked about the variables, defining the variables. You can ignore anything that says C++. Just ignore it. We're never doing C++. And now we're going to go into the robot initialization. Now this is going to be kind of Java-y abstract stuff, so I wouldn't worry about it too much. But this is kind of This is where you put any code that you want to run only one time, only when the robot first turns on. In fact, I could talk about this right now. So robot init is like, it will run once when it's turned on. Autonomous init is if it's in autonomous mode, then it's going to run once when it first turns on. Teleop is the mode in which you actually control it. So this is the same when you first turn on teleoperated mode. You want to do this code. There's a test mode, so you would run any code here. So all these different things are code segments or places to put code for different states of the robot. So if you wanted to code something when it's teleoperated, meaning you're using your controller, it would go here. If you want to code something for when it's in autonomous mode where you don't control it, it would go here. And they actually have 2 things for us. So we're going to dive into that in a second. Let me just see if I'm missing anything. And pretty much what I'm doing is what I want all of you to try doing. I want you to go through this, type it out, and kind of understand it as you read it and type it into your own section. So yeah, simple autonomous example. It tells us that this function runs once each time and enters autonomous mode. So anytime you switch it into autonomous mode, it's going to reset a timer. So it goes to 0 and then it starts it. So you have a timer that's going 0, probably milliseconds. And then we have code that if it is in autonomous mode, what you want it to do is check what the time is. So this is saying this timer that gets reset every time we go into autonomous mode, check. And if it's less than 2 seconds, your robot should be driving. And what's cool is that we're going to look up what arcade drive does in a second because that takes 2 parameters. But I'll tell you now, the first parameter, I'm pretty sure is what gives it its speed. So we're saying go at half speed. And I believe this parameter might be what tells it to turn. I'm going to have to check that though. And then otherwise, if the timer is no longer less than 2, so after 2 seconds, when it's 3, 4, 5 seconds, the motor should be stopped. And these are all codes that are done for us. We are going to learn these codes as we just need them and have to look them up. Let's see. Same codes over here. And then, as promised, let me just look at the arcade drive. Let's see what it takes in. The cool thing about coding is it's set up so if you don't know what anything is, you can highlight over the function that they made for you, WPI lib. And it gives you a brief little definition. Arcade drive method for differential drive platform. That's the engine we're using. Calculates values will be squared to decrease sensitivity. That's some math stuff you don't have to worry about. What it does do is it takes in 2 parameters, 2 inputs. One's x speed, one is z rotation. I was right. So x speed tells it how fast essentially it should go. And it takes in any values from -1 to 1. 1 being the fastest, the motor would spin one way really fast that way. 0 would not move. -1 would be making the motor go the other way. So essentially backwards, forward is positive. The second input, now they have it at 0. They don't want the robot turning, but it takes in a value -1 to 1, and that corresponds to its clockwise position. It's rotation rate. So I guess I'd call it like its angular velocity. So if I really wanted to, if I change this to like 0.5 as well, it'd be going 0.5 speed forward, but also turning at a rate of 0.5. We'd have to look more into like, well, what is that exact measurement? How fast is it spinning? What does 0.5 represent? And when we're looking at it in like miles per hour or meters per second. And yeah, so last thing, let me just show this too, but I'll get to the point because now you're just hearing me talk about all these different things. But this tele-op period is when the robot is being controlled with a joystick. And we're basically saying, take the robot that we named mRobot Drive. We want to use this function on this robot. called arcade drive. Arcade drive takes in a X speed and a rotation speed. We're saying on your controller, your joystick, we want this robot to go however fast our joystick is being pushed in the Y. So if it's like full throttle, it goes fast. And then, sorry, can't see the camera. We also want to be grabbing the horizontal or the X direction of the joystick, and that will be how much we're turning our angular velocity. Yeah, so those things on test mode. And that is really just like the very basic first program. Like that's how you get your robot to drive. Now there's much more advanced features we're going to work on later. But just how I went through this is how I would recommend you guys learn this. You, step by step, read what they say. You create your project. They literally number it for you. They, in this one, had you use one of their pre-made templates. They showed you the whole thing. It's in robot.java. And they even kind of parse out portions of the code and they gave descriptions of like what's going on there. That's how you start understanding like, oh, this is kind of what's happening. Because a lot of these words don't instantly make sense. But as you read their descriptions, which are much better than my talking about these things without really going into detail, you'll start to understand like, oh, this is what this code does. This is what this code does. And the more you see it, the more it kind of repeats, the more you're going to be using these things kind of over and over and over again. This is just about over, but the last thing I do want to try, I don't know if this will work, but we're going to try to see if we can simulate this. So there's a simulate on desktop. Press this. Let's see. Ideally, if we had the robot with us, we would connect it and we would turn it on, and then we would say, oh, in autonomous mode for 2 seconds, it just drives for 2 seconds. And then in teleop mode, we can control how fast it goes and how much it turns with the other one. But we'll see if the simulator will let us see that same thing. I'm telling you now, it won't be that exciting. It's very old school looking. Okay, so let's go to live window. Let's show what this little car looks like. That's our robot. And we're disabled if I put it in autonomous mode. Remember the code says that when you first go to autonomous mode, you are going to drive for 2 seconds. Because what happens is when you go to autonomous mode, it will reset your timer back to 0, start it so it starts counting up. So then it goes 0, 0.1, 0.2, 0.3, blah, 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 blah. And while it's under 2, while that timer value is under 2, it will start to drive at half speed. So let's see that. So for 2 seconds, you see our car's driving forward, and then it went longer. 2 seconds is too little. Let's change this to 20. Restart the simulation. We restart the simulation. There we go. So now if I go into autonomous mode, it should last for 20 seconds. You can even see here's the timer going. And once we get to 20, you're going to see it's going to stop moving. And this is the percent output of the motor. Oh, it stopped. That was longer than 20 seconds, though. That's interesting. That's a potential bug. And just to show you, maybe we want our robot, when it's in autonomous mode, to just spin really fast and not move anywhere. So let me save. Let me refresh. And again, this is far more exciting with a physical robot, but we go to autonomous mode. And for 20 seconds, these arrows are telling us that it's turning a lot. In fact, it's turning at 1.0. That means that the left motor is like doing all the cranking. The right motor is not moving. So it's like fully making it go clockwise as fast as it can. It's just going out of control, spinning. Which again would be much, much cooler to watch in person. Oh, yeah, it does go for 20 seconds. It was running while it wasn't disabled. When I switched it over, it was already at 6 seconds. That's why. That's not a bug. And then teleoperated mode. I don't have a joystick pulled in right now. So it probably won't work. Yeah, it's actually telling me you have an error. You don't have a joystick plugged in. What I probably could do, though, let me put my keyboard as my... Oh, sweet. Use my keyboard. So now it's in teleoperated mode. And instead of using a joystick, I can use my keyboard. And because it's a keyboard, not a joystick, it goes by like how hard I press the key. So if I fully press the key, I'm giving 100% or 1.0, and it's going. Otherwise, it gives... This is the other direction. This is doing like WASD now, right? My W's and my D's let me do my rotations. All right, so ideally, if you have everything installed, I would love for you to kind of do that same thing I showed you, using either my video or using the documentation. Ideally, the documentation, because you learn through reading it, doing it, not me showing you and having you copy after me. Yeah, so hopefully this is somewhat helpful. I'm going to stop the video now. Again, this is almost 100% not going to be edited, so it's going to be very long, and me talking more and more is just making it even longer, so apologies, but watch it on 1.25 speed. Maybe that will be better. All right, everybody. Hope this is helpful. I will see you next time. I was going to stop the video by stopping the debugger. That's not how that works. There we go. Have a good day, everybody. It's still going. It's still going.